So in the previous exercise, what we have learned regarding length of arc. When the equation is in terms of y, length of arc will be square root of 1 plus dy by dx whole square integral a to b. Limits are given to us. Now in this one, second part, curve in parametric form. What they'll give you, find the length of curve question, x value and y value. Separate curves they'll give to us. Means suppose first curve is this one, second curve is in this way. So when two curves are there, one is equation in terms of x, second one in terms of y. Or we can consider the first curve in terms of t and second term in terms of g of t. Or we can consider in terms of t, or else they can also give you in terms of theta. So when theta is given to you, x value in terms of theta, y value in terms of theta, suppose x is sine theta. Sine theta curve, you know, sine theta lies between zeros and 1, and cos theta, g of t is cos theta, suppose. Cos theta also one curve. Both curves are connecting to one another. If two curves are there, or if the question is in this way, find the length of the curve when x is equals to something in terms of theta, sine theta, or sometimes it will be in terms of t. If at all in terms of theta and y, two equations are given to you, two curves we can say, and we need to find the length of the curve, total curve from this one, from here till here. So to find the length of curve, if limits are given to you, immediately what you have to, previously there is no x, only y terms are there. In the previous questions, what we have done, find the length of arc, length of curve, what we used to do, integral a to b square root of 1 plus dy by dx whole square, that formula we have taken. But here we can't use that formula. We have to go through with this one. Length of arc from the curve when two functions are given to you, two different curves are given. That time the formula will be a to b. These are the limits given to us. Limits means x values. These are the values. Then dx by dt whole square plus dy by dt whole square dt. If at all the question is in terms of theta, that time we'll consider this one to be d by d theta of x whole square plus dy by d theta of y, d by d theta of y whole square within the square root dt. The limits are from a to b. To find the length of the curve when x is given and y is given, theta values are given. Two functions are there. In the previous questions, what we have learned? We learned that only y function will be given to you. By using that function, we know how to find the length of arc. Now what is that? When two functions are given, first thing, you need to consider this formula first. If the question is in terms of theta, then the length of theta will be a to b square root of dx by d theta whole square plus dy by d theta whole square d theta. Then x value is there. We'll consider our solution in this way. First we will consider x is equals to this. Whenever the question is having two variables, that time it is known to be a parametric form. Okay. Then e power theta sine theta is x value. You have to differentiate both sides with respect to theta. Then it will be d by d theta of e power theta sine theta. Then further expansion, this is in uv form. U derivative of v, sine theta derivative, cos theta, plus v derivative of u. This is dx by d theta. We can also write this one in terms of, by taking e power theta common, cos theta plus sine theta. This is dx by d theta. Similarly, second is y is equals to e power theta cos theta. Differentiating both sides with respect to theta means dy by d theta is equals to d by d theta of these two things. So uv form, u derivative of v plus v cos theta as it is, derivative of e power theta is e power theta itself. Again e power theta common. If you write positive term first, this is cos theta minus sine theta. Or you can also write this one e power theta common, minus sine theta plus cos theta is cos theta into cos theta minus sine theta. These are the two equations we got. Once again check this one. To find the length of the curve when x and y, two curves are given to us. That time, this total thing is known as parametric form. In this parametric form, when limits are given to you, first you have to take first one. If theta is given, with respect to theta we should do. If the question is in terms of t, that time d by dt you have to consider. Similarly for y also, you have to differentiate both sides. Once we got those answers, we have to substitute in this formula. Length equals to length of curve integral a to b, limits are given to us 0 to pi by 2, square root of dx by d theta whole square. So they'll get square. So e power 2 theta if we'll square, this one cos theta plus sin theta whole square. Then extend the root plus dy by d theta whole square. So whatever answer we got, we have to square this one. E power 2 theta cos theta minus sin theta into d theta. Now further simplification. If you are good in simplification, you can easily get this answer. E power 2 theta common. Then cos theta plus sin theta whole square plus cos theta minus sin theta whole square d theta. Next step, 0 to pi by 2. E power 2 theta is common. A plus b whole square plus a minus b whole square condition. This identity we have to use. If we simplify this one, what you will get? 2 times of a square plus b square. Not visible. So we have a plus b whole square plus a minus b whole square. That is 2 times of a square plus b square. If you simplify this, you'll get this one. So here we'll get 2 times of, we are simplifying these two things, cos square theta plus sin square theta into d theta. So this will be integral 0 to pi by 2 square root of e power 2 theta into 2 into 1. This is d theta. In next step, 0 to pi by 2, square root is taken as e power 2 theta power 1 by 2, 2 power 1 by 2 d theta. Then in the next step, 2 cancelled. 2 power 1 by 2 is root 2 outside the integral because it is a coefficient constant that is taken out, e power theta d theta. This will be root 2 into e power theta integral is e power theta, then 0 to pi by 2. So we will get root 2 e power pi by 2 minus root 2 into e power 0. This will be root 2 into e power pi by 2 minus root 2 into 1 units. This is the answer for length of curve.